This video is a brief description of the nodes. There's two kinds of nodes in SWM, junction nodes and storage nodes. Actually, there's several more than that. These are the primary ones that get used a lot in practice. We're going to talk about junction nodes in the next few slides. Important concepts of nodes, whether they're junction or storage, is an invert elevation and flooding. So a junction node is an ordinary junction that connects hydraulic elements such as links or pumps. A junction attributes that are important are the invert elevation, which is defined as the bottom or the elevation of the bottom of the node, the maximum elevation, which will be the elevation of the top of the node, and there'll be a picture on the next slide to explain those two relationships. Some guidelines, you can set the land surface to the maximum elevation, so it's invert elevation plus maximum elevation would get you to the land surface, and you can use that to plot a profile grade line in SWM. Alternatively, you can set it to land surface plus a little bit of extra to handle overland drainage, which is a fairly advanced concept. Won't be discussed in this video, but it is done later in the course. When the program runs, the depth of the node is computed. But the node itself has negligible storage. It has zero area. And so the depth is completely controlled in an ordinary node by its adjacent links. So here's a junction node. Here's the invert elevation. That's the invert of the junction node. It's this elevation right down here where the cursor is going cursive red baron. Oh, I didn't want that to move. There we go. The maximum elevation is whatever this elevation is up here. So for example, if the junction elevation is 100 feet, if the invert elevation is 100 feet and the node is 10 feet tall, if we go back here to the node input, we'll see the invert elevation is set at 1, maximum depth would be 10, and when we go ahead and plot the section, it's not going to be a very interesting plot. The invert elevation is shown right here at 1, and in this case the max depth was set at 10. We rerun the program and it should read, there we go. The max depth is the 1 plus the 10 to put the profile grade at 11, and then you can see the pipe height here, which is 1 foot, is shown. If you don't supply a max depth, it uses the larger diameter of whatever pipe connects to it. If flooding occurs during computation, during computation it's quite possible for the junction depth to be higher than the adjacent pipes. That's the case where the pipes are surcharged, but the node is not flooded. Alternatively, if the water collects in such a way that the water surface elevation goes above the height of the junction, for example in the drawing here we have a slight flooding in the street, this would be the case where the pipes are surcharged, no change there, but now the node is flooded. And when the node is flooded, we're presented with a couple of additional considerations we have to use for analysis and ultimately for design, is whether or not we want to consider that flooding as a node flooded attribute or convert the node to a storage element and explicitly try to explain the depth storage relationship. If we use the junction node, one additional attributes we supply are ponded depth and then the area that's ponded, and it essentially treats the node as a vertical wall storage tank. This is often a good strategy to take when you're initially building a model in order to keep track of what nodes flood and don't flood, and then go back later during the analysis and convert those nodes to storage elements where you have a depth storage relationship. Okay, well, this will conclude this recording, and the next video is going to run through an example to motivate use of SWIM.